EFCore provides logs that help us determine the time taken by a specific query to finish. The logs also display the actual SQL query that was executed on the database end. This means that we have a very transparent way of knowing the actual command in SQL syntax and also about the time it took to complete. Hence, we can diagnose queries that execute too slow, possibly because an index was missing on database. And in this tutorial, we also examine how to use tags with logs. In the previous tutorial, we turned off all logs so that we could focus on SQL query logs only. The first thing we do now is to configure logging for SQL commands. Because we disabled everything, now we will configure logging so that logs for SQL commands appear for us. For this, open the program.cs file and locate the statement where we added our project context. Just add a log to call next to the use SQL server call. This call logs all information to the console output. Now the log messages will show the time in milliseconds along with the SQL syntax that was executed on the database side. And now let's practically run a SQL select query and display the time taken for completion. Open the Solution Explorer and locate the index.cs HTML file. Double-click and open it. Recall that we already have a link called click to seed for seeding the database. Add an action link, anchor link called select all items just next to it so that we can click it to run a select query. This link is connected to a handler called select_1. And next open the backing class and add a handler called onGetSelect_1 async. Inside this handler we have fired a query await_context.items.toList_async. This query will bring all the columns of all the records of the items table. Run the project to open the home page. We observe that some log items have appeared in the console window. These SQL commands are due to the initialization of DB context. Come to the home page and click on the Select All Items link to fire the select query and allow the query to finish. We observe that the log window shows a log for the select query. The command execution time has been mentioned in the brackets with executed command and followed by the bracket time in milliseconds. This is how we can read the log and the time consumed by a query. As you must have already seen, the console log is fairly bulky, and if you run too many queries, then it might be difficult to locate a specific query. Another problem is that the final SQL queries, they might look very different from the LINQ query. So there could be some difficulty in determining the log entry that corresponds to a particular LINQ query. The above problem can be solved by using query tags with the select queries. Open the index.cshtml.cs file and modify the handler for the select query to add a tag to the select query. Context.items.tagWith followed by some string. The tag is added, as you can see, by using a method called tagWith. A tag is any readable string. And run the project again, and this time notice that the tag string appears in the log window. So now you know which query appears at what place. And this is how we can use tags. We'll close it right now. Thank you. We shall use various methods to calculate the sum of prices of all the records in the items table. We will also take note of the times taken. Usually the best results are obtained if tracking is disabled for read-only queries and if select is limited to just the columns needed, and if possible by allowing the calculations to take place in the database. But keep in mind that each query has its own circumstances. So never assume results. Test, test and test is the best way to determine the optimal query in each case. Before I take up my exercises, it is important to know that I shall use various methods for running a small query just once. But this is not the correct way of determining the performance of a query. A more sophisticated library such as benchmark.net is a better option for measuring performance because it can provide statistical indicators such as mean, standard deviation, median, etc. I am only demonstrating the various possibilities of running a simple sum calculation. The methods are arranged in the increasing order of recommendation, but don't take these as if these are final results. I am just demonstrating that there are various possibilities of running a query and some methods might be better suited than others. In our first method, we shall run a select query and obtain all the columns, even the unnecessary columns also. So this will be a select star type of query. We shall add an anchor link to the home page and bind it to a click event handler. You can obtain the completed project from the attached downloads. I will show the query that we shall run, then you can check the downloads for the whole project. First, this query obtains all the items. After that, a for each loop is run to add the price. Run the project to open the home page and click the sum after select star anchor to allow the query to complete. Take note of the time taken by this query. In my example, it takes about 26 milliseconds, but it will be different in different computers. And in fact, this is not the right way of doing it also. I am just doing it for the sake of it so that we just have a simple idea. Next, let's take method 2, no tracking. Tracking can be disabled for read-only scenarios, and it can lead to an improvement also, because we do not need tracking for read-only scenarios. Tracking is basically for tracking the updates, etc., or the changes in the records. But when you are simply selecting a query, then there is no need to track it. Let us now run this query. We have used the as no tracking method to disable the overhead due to tracking. Open the home page and click the sum no tracking anchor and examine the logs. The query now takes 3 milliseconds, which is better than the time in the previous method. Usually, selection of a no tracking will always give you some improvement in the performance. So this you can take note of. Another improvement of performance is possible. Next, let us restrict the selection to just the price column. And this is the query that we shall execute. We have used the select method to extract only the price column from the database. Open the home page and click the sum after select price, this anchor, and examine the logs. The query now takes even lesser, which is better than the previous time. This is expected because taking all the columns is definitely performance inhibitive. It is better to take just the required columns as we have done now, and you will see an improvement in query. And it is even better to postpone the database operations to the database. Let them take place in the database. Database operations proceed most efficiently if they take place in the database. For example, a sum query in the database might be better instead of first querying all the records and then using a loop to add them up. Consider this query where sum async is used to perform the sum totaling in the database. You can run this query and measure the time. I'll close it right now. Thank you. Lazy loading is a great ORM pattern that automatically loads dependent or child data when it is first accessed. The delayed loading is both an advantage and a disadvantage. This tutorial explains both these aspects and the associated pitfalls. EFCore doesn't enable lazy loading by default. So this is a point to be noted, and we'll talk about this in a moment. Before I explain anything else, let's learn how to enable lazy loading in an EFCore project. There are two methods of doing this, but I'll cover the simpler of the two. First of all, install the NuGet package called Microsoft.EntityFrameworkCore.proxies. This package handles most of the complex logic for us. And after this, open the program.cs file and locate the add-db context code and add the option called use lazy loading proxies. This will turn on the lazy loading scheme. The next thing is to modify the model classes and mark the child collections as virtual. For example, in our project we have an item class. This class contains a collection of related invoices. If we want to use lazy loading for this collection, then we have to mark the property as virtual, like public virtual I collection, whatever. So this property has to be marked as public virtual. This will enable it to be loaded in a lazy manner. So with these steps, lazy loading is enabled for the invoices property of the item object. And now let's see it in action, and you will understand more when I show the code also. Next, let's add an anchor link to make a call to the database. This will help us see how lazy loading works. Open the Solution Explorer and the index.cshtml razor page. Add an anchor link called lazy load of invoices as you are seeing here. This is connected to a handler called lazy load. And next, let us open the backing class index.cshtml.cs and add the handler. You can obtain the source code from the downloads, so I will show just the handler part. You can obtain the code and examine the whole project. This code has two simple for each loops. The first loop, the outer loop, fetches all the records from the items table. The inner loop, it accesses the invoices collection of each item. So now we are at an important point. It is at this point that lazy loading comes into action. It automatically makes a database request to fetch the related invoices of an item. It is at this point, the point of access, the point at which this property is accessed for the first time, it is at this point that a request goes to the database. It automatically makes a database request. It fetches the related invoices of an item. The point to note here is that lazy loading is an automatic action. Data is loaded just at the point of need. So this is what has been the plus point of lazy loading. But there is a hidden problem here. Let's turn to the logs. We observe that there is an explosion of SQL queries. There is a trip to database each time the for each loop runs. Because whenever the property invoices is accessed, each time the for each loop runs, the property invoices is accessed, and at that point a fresh request to the database goes. This might not be desirable. This can seriously hamper performance because of a trip to the database. And the worst part is that it all happens without any suspicions. Who would suspect two simple loops to raise too many trips to a remote server? It is because of this pitfall that lazy loading is no longer enabled by default. So now you must be clear why lazy loading is not enabled, and we have to take such a roundabout scheme to get it enabled. So let's now come to the solution. My one-line answer is avoid lazy loading if possible. A better strategy is to use eager loading by using include operator. We can add another link and add a handler called eager load to test the whole thing. The source code has been attached as a download, so you can examine it there also, but I'll explain. As you can see, we have used the include operator to include the invoices also. We can now run the application and examine the logs, and we verify that there is now only a single query to the remote database. So this is an optimization that you can make if required for your situation. Thank you. A query can first store the entire result set into memory and then use a for loop to process each item. Alternatively, it can stream each result into a for each loop one by one. We can examine both these possibilities in this tutorial. A query that evaluates to a list or array buffers the entire result set into memory. Consider this code that uses the toArray method to obtain an array of items. This causes the entire result set to be buffered into memory. It might be faster and efficient if the count of items is small. But if the number of items is large and each item is heavy, then it will have a memory overhead. Memory requirements could increase, leading to a fall in performance. So you should be aware of a possible pitfall when you use toList and toArray methods. If your result set is large, then streaming will be a better option. Consider this code that will stream the items one by one. The query identifier, it obtains an iQueryable by using the where operator. The for each loop streams each item one by one. This will be very efficient if the number of items is very large. Streaming has a fixed overhead, so it doesn't matter whether we stream one single item or we stream thousands of them. Hence, streaming is not an every time solution. It is more suitable if your query is expected to return many items. However, if your query is expected to return a fewer items, then buffering would be better. Sometimes your query is built with a chain of operators. It could be more efficient to use as enumerable to stream each item before it is processed by subsequent operators. Let's take an example. In this query, a subset of items is first obtained by using a where operator, and then a function called myFunction has to be called on each item. So we have a chain of two where operators. There might be a memory overhead if we extract all the results of the first where operator into a list and then call the next where operator on the list so obtained. So it might in fact be optimal if we use as enumerable to first obtain a stream and then call myFunction one by one. So these are the subtle things that you can keep in mind. Thank you. Suppose your database team have already provided you an optimized query in SQL syntax. Or let's say you have a legacy old setup that makes it compulsory to run a query in a raw SQL syntax. In such cases, you can use the from SQL raw extension to make that call. Let us suppose that we have to execute a query that selects all columns from a table and gives an alias of say fees to one column called price. Select id, name, price as fees from items. So how do we execute such a query and get the collection into our project? The first requirement of C# side is that we must have a model class that contains the exact same compatible properties as the columns sent by the SQL query. The names of the properties must also match the names of the incoming columns. The SQL query cannot bring related data to populate the foreign key properties that we usually have in our code first model classes. So whatever model we have in our database, it should not support foreign key properties. And let's see how we can do it practically. We must have a model class that contains all the same exact properties. So open the item.cs file and add this model class. We could have added it in a separate file also, but since this is a tutorial, I have added it in the same file. The model class has three properties: ID, name and fees, which match the columns returned by the SQL query. And notice that this model class has been marked with the keyless attribute. It indicates that this is a class just for holding data. It doesn't have a primary key. It indicates that EFCore should not track its DB set for updates and deletes. So this also means that this class doesn't support foreign key, etc., as we already told. The source code has been attached in the downloads. You can obtain it from there, but I have shown a part here. The DB set for this model has to be added to the DB context class also. Locate the entries for DB set of items and invoices. I provided the source code in the attached download, so you can have a look at there also. Add an entry for the DB set of this model class. And once you have added the DB set, EFCore will attempt to create a table in the database because the default behavior is to create tables for all DB set entries. Obviously, we do not want this to happen. So for this, override the onModelCreating method and use the toView method of the Fluent API to map the query to a view. This prevents the table from being created. This is what you should be doing for every such model that you want to add to your project. And now everything is in place and we are ready to execute the query. Open the program.cs file and scroll towards the end. Add a map-get API for testing purposes. We could have added it to a Razor page also, but since I have to just show an example, so I have added a map-get API so that I can show a test here. This API will be called from an endpoint, let us say my data, as I have shown here. The query in the SQL syntax has been provided by a database expert. The from SQL raw method is used to execute the query. The result is obtained in a list and the list is returned as a JSON by this API. And finally, you can run the project and open the my data endpoint. We verify that the JSON is displayed as expected. All the names like fees, they are all shown in the JSON as we expected. Thank you. Raw SQL queries and stored procedures can be executed with the from SQL raw extension. It is very common that these queries and procedures require parameters on the basis of values entered by a user. User-provided parameters are often a source of SQL injection attacks, and in this tutorial, we learn how to pass parameters in a safe manner. First, let's learn briefly about why stored procedures are used. Stored procedure is a good tool, firstly to reduce round trips to a database. Secondly, to make efficient use of the database team who can write optimal queries in the SQL syntax, in the SQL language they already know, they are already comfortable with. Thirdly, to make efficient use of the database server, because too many complex joins, groups, etc. might be needed in a typical real-world application, and every such thing can take place in the database server itself. And fourthly, we can say that legacy projects often have many stored procedures already written into the database. So you have to execute them using your C# side. You are forced to do that because they are already written into the database already. First of all, let us learn how to execute a stored procedure that doesn't accept any parameters. Suppose we have a stored procedure called getAllItems that returns a list of items. First of all, you will have to add a model class to match the columns returned by this stored procedure. This has already been explained in detail in the previous tutorial, so I'll not repeat it here. Now you can run a raw query execute dbo.getAllItems as you are seeing here. This raw query will run without any parameters, and this is the syntax that you can use for running a query. Let's next turn to stored procedures or queries that accept parameters. Firstly, the parameters have to be sanitized before they can be passed to the database engine. This is for SQL injection attacks. For other problems also, so some sort of standard sanitization is required. Secondly, the parameters must also not contain invalid characters that can cause the query to fail because of syntax conflicts. Both these problems can be taken care of if you follow the standard method that I am going to explain. Suppose we have to execute a stored procedure execute dbo.getAllItems at s1. In this statement, the name of the parameter is s1. Let's have a look at the wrong way of calling this stored procedure. The wrong way of calling this stored procedure is to use a string concatenation to construct the query string. You might be tempted to do this, but you should never do this because it is prone to SQL injection attacks. So how do we solve this problem? There are two ways of solving this problem. The first is to use placeholders, and the second is to construct a DB parameter or SQL parameter and pass it as the parameter value. First, let us examine the use of placeholders. Again, suppose we have to execute our stored procedure execute dbo.getAllItems at s1. In this statement, the name of the parameter is s1. The code for calling the stored procedure has been shown here. First, store the parameter value in a string variable s1. This value is passed through from SQL raw function by using the placeholder syntax as you are seeing here. Concatenation is not done, but it is passed in a roundabout manner as you are seeing here. It looks very similar to string.format, but it is not the same thing. The function from SQL raw actually creates a DB parameter object out of s1 and then inserts it correctly at the place where placeholder 0 has been used. There is an alternate way of doing the same thing also. The above code could have been done with the string interpolation syntax as well. String interpolation syntax, it uses a $sign to replace the numeric placeholders by the name of the identifiers. In this code, we have used $execute dbo.getAllItems curly braces s1. In this case also, the value s1 is converted to a DB parameter and executed. And let's now see where we can construct a DB parameter on our own. We can construct a DB parameter out of a value and then pass it to the from SQL raw function. In this code, we have constructed a DB parameter of name s1. The value has been passed as the second argument. This syntax allows us to use various overloads of SQL parameter to specify direction of parameters, data types, etc. So we have a lot of possibility of fine-tuning the parameters if we use this method. And notice that the parameter is now passed by using SQL placeholder at s1 in execute dbo.getAllItems at s1. So you can take note of this syntax. This is how we can execute stored procedures and pass parameters in a secure manner. Thank you. EFCore uses batching to execute bulk updates in a single trip to the database. You can always fine-tune your code by carefully sequencing your statements so that EFCore can batch them up. In the second part of this article, we have a walkthrough to analyze a piece of code that triggers various trips to the database server, and we explain how that same code can be simplified and optimized to just one single trip. Let us first understand how is batching done. Batching is an automatic process. It is an optimization by EFCore to prevent multiple round trips to a database server. The EFCore engine It uses its entity tracking feature to make this optimization. Consider this code. Let me explain it line by line. First of all, we extract an item and make an update to its price. This translates to a SQL update statement. After that, we add two items to the items table. This translates to two SQL insert statements. These changes could need 3 different trips to the database. But EFCore uses entity tracking and batching to make these changes in a single trip to the server. So instead of sending all the statements one by one to the server, it makes a trick and uses something to send all the 3 statements in one go. So all these 3 statements are executed on the server side, on the database side in just one trip. Hence, you can sequence your statements to ensure that the save changes call takes place at the most optimal point, so that most of the statements are collected together and batched by EFCore. EFCore combines and clubs a number of statements for batch updates. The actual number of statements clubbed together is dependent on the database provider that you are using. You should refer the specific documentation for their recommendations and defaults. It is possible to set a batch size for your specific needs. Consider the code shown here. In this code of add DB context, we have set minimum and maximum batch sizes. But the EFCore team recommends that this tweaking should be done on the basis of extensive testing and benchmarking. It is better left to the default values, but it is always there when you need it. And finally, let's take a case study. We take a case study of bulk updates. Consider this code on the C# side. The objective is to update the price of all items by a certain amount, say 10 or 20. This is a simple code, but there are some problems. The first problem is that we must fetch all the columns for tracking purposes, even though we need only the price. Since we have to bring all the columns, this has a possible performance penalty. Next, we have the for each loop that runs to update each item. But EFCore bulk updating feature, it ensures that there is a single round trip to the database server, which is good, and we are safe here on this point. But there is now a problem at the database end. Even though we have a single trip to the database side, but each item has to be independently updated because there has to be a dedicated update statement for every item. So if you have 10 items to update, then on the server side now, there are 10 update statements that will run. Even though the batching system, it sent all 10 of them together to the server side, but on the server side, on the database server side, they will run in the form of 10 different update statements. And now let me give you a simple solution to this problem. Now why don't we use execute SQL raw to execute our direct SQL query? Update items set price is equal to price plus 10. This query will update the entire table in just one go. Think about it. Thank you.